Hey guys, welcome again to the Maths Club. If you are just joining us, so welcome. I will encourage you to subscribe to our channel and hit the notification bell if you have not, so that anytime we post something new, you would be the first to know. And if you're a returning viewer, welcome back to the Maths Club. Over time, we're looking at algebraic processes, and this will be one of the last videos under its linear inequalities. So let's get right into it. What are linear inequalities? It's just a mathematical expression that is comparing two statements or two expressions. An example is, I am 5 years old. That is one statement or one expression. And the other statement expression could be, my brother is 20 years old. Definitely, my age is less than my brother's age. Of course, I could also say that I have at least 3 children, right? So if you look at it, that could be me saying I have 3 or more children. You guess it could be 3, it could be 4, it could be 5, it could be 6. So things like this, where you're using the inequality symbols, you're dealing with linear inequalities. So what are those inequality symbols we're talking about? Greater than sign, less than sign, greater than or equal to sign, and less than or equal to sign. So what's the difference between equations and inequalities? Of course, you're already used to x is equal to 5. X would always be equal to 5, except it's changed. X will not be equal to 6 because we've definitely said that x is equal to 5. Same thing applies to when you say 5 plus 1 is equal to 6. You consider what's at the left hand side, which is 5 plus 1. I mean, if you resolve it, that is 6, right? It's also equal to what is at the right hand side. So just saying that when you do equal to, you're saying that these two things, they are equal. X is equal to 5, that means x is 5, and of course at the right hand side 5 is 5. If I say 5 plus 1 is equal to 6, I'm saying on the left hand side 5 plus 1 is 6, and the right hand side 6 is also 6. So you're saying these two things are equal. But inequalities, it indicates a range of possible solutions rather than a specific value. So if I said x is equal to 5, x is 5. But if I said x is greater than 5, you can see that there's already a range of possible solutions. It's no more x is equal to 5 again. X is greater than 5. That would be, it could be 6, it could be 1,000, it could be 1 million. As far as there's no like stop gap, it's constant. That is the range of possible values. So that is the difference between equations and inequalities. Equation gives you a specific value. It ties a variable to a specific value, a variable like x to a specific value like 5. But an inequality gives a range of possible solutions. So it doesn't tie to a specific value. It could be greater than or equal to 5, which is 5, 6, 7, 8, 9, 10, 1 billion. You can see a possible range of values. Look at this expression on the number line. So this is like a number line. It's showing you that it continues at the left and it continues at the right. So we just pick the period between 1 to 7. So for x is equal to 5, this is like an equation, right? So go to 5 and then we draw a circle around it, and we're going to shade inside that circle because x is definitely equal to 5. You see how we'll shade on the number line when it comes to a question that has inequalities. Great, so look at the example. We have x is greater than 5, still the same number line. But at x is greater than 5, we draw a circle. This time we don't shade because 5 is not included. If 5 was included, we will have shaded it. But when x is greater than 5, 5 is not included, so we don't shade it. And since greater than 5, that means it could be 6, 7, 8. That means that it is going towards the right direction. As you can see, the arrow follows the sign of the inequality. So if it's going to the right, the arrow will go to the right. And you should also put your arrow head to show that it is going towards that right. This one says x is less than minus 1. Because minus 1 is not included, we don't shade the circle of minus 1. And then the arrow follows the direction of the inequality. So you can see this is going to the left. So it's going to the left. Because anything less than minus 1 is like minus 2, minus 3, minus 4, things like that. This one is x is greater than or equal to 3. At 3, we draw a circle. But because 3 is included, we shade that circle. And then the arrow will follow the direction of the inequality sign. So you can see x is greater than or equal to 3. That will be 5, 7, 10, 20, and so on and so forth. X is less than or equal to 5. This is 5 because there's an equality sign to it, so we shade it and then we draw our line. So that's basically the difference. How do you resolve linear inequalities? First step, that you simplify the inequality if it is needed. Then isolate the variable on one side of the inequality. So it could be at the left hand side, at the right hand side. Where is variable? All those x, maybe y, all those things. Put everything in one side of the inequality. Perform operations like addition, subtraction, multiplication, division. I mean, this is like standard practice. But you have to remember something, that if you are dividing or you are multiplying by a negative number, you you have to flip the inequality sign. I'm going to say this in practice and then represent the solution on the number line, but I won't be doing this. But I encourage you to actually, anytime you come up with a solution, try to draw it on the number line. It will help you. Let's see this example. It says that which of the following pairs of inequalities is represented on the number line. Let's do this one together. So if you look at this now, at -2, you can see that it is circled and it's shaded, and at 1 it is circled and it's shaded. So following that principle of the sign, so I could come here and say x is, which side is leaning to the left, so it will be a less than, but because it's also shaded here, it will be less than or equal to -2, and this one here will be x is going to the right, so that will be greater than, but you can see it's also shaded, right? So that will be greater than or equal to what? 1. So this is the solution for this particular question. So that will be option C. Great. Example 2 states that we should find a range of values of x which satisfies the inequalities. We have two inequalities. 4x minus 7 is less than or equal to 3x, and 3x minus 4 is less than or equal to 4x. Let's take from JAMB 2008. Let's solve this together. So we're saying 4x minus 7 is less than or equal to 3x. Let me solve this part first. So I'll isolate all the x's to one side. So that'll be 4x minus 3x is less than or equal to 7. So our x is less than or equal to 7. Then for this other guy, which is 3x minus 4 is less than, okay, or equal to 4x. Let me take it over to one. So that'll be 3x minus 4x is less than or equal to 4. If I carry it over like terms, and minus x is less than or equal to 4. We're told that if we're dividing or multiplying both sides by negative value, our sign will change. So if I divide this by minus, I divide this by minus, my sign will have to change. X will be greater than or equal to -4. Now we have two different values, right? So we could say x is less than or equal to 7 and x is greater than or equal to -4, or we could just join them together. How do we join them? Which of these two guys is lesser? This is lesser. What will happen to the lesser one is that I'll just flip the side. So if I flip the sides, I also flip the sign. So -4 will come here and x will come here, and then the sign will change. That'll be -4 is less than or equal to x. I just flipped both sides and the sign will also change. So let me now join them together. That'll be -4 is less than or equal to x, which is what I have here. And then that x is less than or equal to 7, right? So I could just say x is less than or equal to 7. This is how you join two different inequalities together. Look for the lesser one, flip the side, and then just write it's -4 less than or equal to x, and do as if you are continuing it and say x is less than or equal to 7. So that will be option A. Example 3 states that we should solve the inequality y plus 2 all over 4 minus y minus 1 all over 3 is greater than 1. I want you to pause the video and try this out. This is like from my 2022. Welcome back. I believe you've solved it, so let's solve it together. The LCM here is 12, so that will be 12 divided by 4 is 3, so 3 open brackets y plus 2 minus 2 divided by 3 is 4, so 4 open brackets y minus 1 is greater than 1. So let's expand the bracket. That will be 3y plus 6 minus 4y plus 4 all over 12 is greater than 1. 3y minus 4y will give you minus y, plus 6 plus 4 will give you plus 10 all over 12 is greater than 1. So if I cross multiply, that will be minus y plus 10 is greater than 12, and that will be minus y is greater than 12 minus 10. Minus y is greater than 2, and if I divide both sides by minus, what will happen to my sign? Great, it's also changed. So that will be y will be less than -2. So this is our solution to this question, and that will be option B. Example 4 is that the distance D between two villages is more than 18 kilometers, but not more than 23 kilometers. Which of these inequalities represents the statements? So this is from WAEC 2021. I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. So we know that D is more than 18 kilometers, right? So D will be more than 18 kilometers. Of course, D cannot be more than or equal to, right? Because the question does not tell us that. It just says it's more than. If it's more than something, it cannot be that thing. But it also now says that D is also not more than 23 kilometers. So of course, D could be 19, 18, it could be 23, but it cannot be more than 23. So this is where you have to be very careful, because it's not more than 23, meaning that 23 is also included. So D is not more, so that is less than or equal to 23. D is not more than 23, so it could be 23 or less. Now, how do we marry these two statements? Which of the two is less? This guy up here, so I'll flip this side. So that will be 18 is less than D, and let me join them. So that will be 18 is less than D, and then D is less than or equal to what? 23. So D is our solution to this question. That will be option D, because D is for the distance. So, okay, nice. So example 5 now states that we should find the range of values of x which satisfies the inequality 3x minus 2 is less than 10 plus x and is less than 2 plus 5x. Take from WAEC 2018. I want you to pause the video and try this out yourself. Welcome back. Let's look at it together. So if you look at the previous example, after we have the two separate parts, we now join them together. That's exactly what's happening here. They've joined these two separate inequalities together. So I can break it apart and say this is 3x minus 2 is less than 10 plus x, and this 10 plus x is less than 2 plus 5x. So let's create like terms. That will be 3x minus x is less than 10 plus 2. 3x minus x is 2x and is less than 10 plus 2 is 12. If I divide both sides by 2, my x is less than 6. Let me resolve this part. So that will be x minus 5x is less than 2 minus 10. Minus 4x is less than minus 8. And if I divide both sides by minus 4, not only would I be able to resolve this guy, but the sign will also change. That will be x now be greater than 2. So I have this and I want to join. Which of these two is less? This guy is less. Let's swap. That will be 2 is less than x. Now let's join together. That will be 2 is less than x, and x in itself is less than 6. So these are solution. Let's see if we're correct. Great. Example 6 is that given that x is greater than y and 3 is less than y, which of the following is or are true? Is y greater than 3? Is x less than 3? Is x greater than y and is y greater than 3? I want you to pause the video and solve this out. Welcome back. Let's look at it together. So we're told that x is greater than y and 3 is less than y. So I could rewrite this and say this like saying y is greater than 3. You know why? Because I can swap. So y is greater than 3. That means our option 1 is already correct. And look at this. If x is greater than y, right, and y is greater than 3, I can write it like this: x is greater than y and y is greater than 3 from what we've done before. So option 3 is correct. Let's look at option 2. It says x is less than 3. X is greater than y. Y in itself is greater than 3. So y is something like 4, 5, 6. And x is even greater than that. So x can never be less than 3 because of this relationship. If y is greater than 3 and x is even greater than that y, of course, x cannot be less than 3. So our answer here is 1 and I. Let's see if we're correct. That will be option C. So now let's look at graphical solutions of linear inequalities in two variables. When we say two variables, we're talking about x and y. So a linear inequality in two variables such as x plus y is less than or equal to 4. There is a region that is represented by that particular inequality on the Cartesian plane. Cartesian plane is simply your graph, your x and y graph. So they're saying that by the time you plot it, there is a region that corresponds to this particular inequality. So this inequality, it divides the plane into two regions, with one side satisfying the inequality. I'm going to say that when we plot it. Take note of this. When you have a less than or a greater than only, you use dash line. But when you have a less than or equal to or greater than or equal to, use solid lines to draw your graph. I will say that in practice. Let's see an example. Example 7 says that we should show on a graph the region that contains set of points for which 2x plus y is less than 3. So I want to plot the graph of 2x plus y is less than 3. Right? So we just need to know at the boundary, like I said, the boundary is where 2x plus y is equal to 3. So if this is we say x is greater than 3. If this x is 3, right? So I'm saying, oh, from this point onward, x will be greater than 3. So this is the boundary, this is where it starts, and this is the direction that you'll be going. So whenever I do something like this, you need to find the boundary position by making this equal to 3, or making this less than sign equal to. It's not depend on if it's less than or less than or equal to. That will be what will determine if it will be a dashed line or a solid line. So here we can say at x is equal to 0, y is equal to 3, and then at y is equal to 0, that will be 2x plus 0 is equal to 3. Our x will be equal to 3 over 2, or 1.5. So this is the point I just need on my graph. So I'll just draw my graph. So this is the x-axis, this is y-axis. So for the scale for the x, I could say let 2 centimeter represents 1 unit on the x-axis, and let 2 centimeter represents 1 unit on the y-axis. That's okay. So this is 1, 2, 3, 4, 5, 6, 7, and this is 1, 2, 3, 4, 5, 6, 7. This is minus 1, minus 2, minus 3. So when x is 0, y is 3, so this is 0, 3. When y is 0, x is 1.5, y is 0, x is 1.5, 1.1, 1.2, 1.3, 1.4, 1.5. So I'll just join these 2 points together. Now, is it going to be a straight line or a dashed line? It's going to be a dashed line because it's just less than. So I will just have to do this as a dashed line. Now, this is the graph of 2x plus y is less than 3. You must write it down. So we're saying here that if I made this y sort of formula, that is y is less than 3 minus 2x, we're saying that the value of y is less than, remember this line here is the boundary. This is where 2x plus y is equal to 3. This is where it's equal to 3. We're not saying the value of y is less than 3 minus 2x. Remember, this is where this occurs, right? This is where the boundary is. So if the value of y is less than, can it be up? No, it will have to be down, right? This is down. The place that corresponds where I will shade. Some books will shade the part that does not correspond. I think New General Maths shades the part that does not correspond, but sometimes you need to read the question and know what to shade. So basically, this area here is the area of 2x plus y is less than 3. It will always be less than, so we'll shade the down parts. Example 8 then says that we should show on the graph the region that contains the set of points for which y is greater than 2. We'll solve this together. For y is less than 2, we also need to find what happens at the boundary. Y will just be equal to 2. So for the x-axis, we're going to use a scale of 2 centimeters to represent 1 unit. And on the y, we're going to use 2 centimeters to also represent 1 unit. So it's just for us to plot our graph. I'll just do something very small since it's just one line. So forgive me that my graph is very small, just because it's something very small. I don't want to stress myself drawing something very large. So this will be 0, this will be 1, this will be 2, this will be 3, this will be 4, this will be 5, this will be 1, 2, 3, right? We're told that the boundary will be at y is equal to 2. So I'll just come here and take my ruler and draw where y is equal to 2. But because it's a less than, it's going to be a dashed line. So let's assume our graph ends here. So because y is less than 2, it's going to be this place under. Because y value cannot be greater than 2. It has to be less than. So anything, so this 2, 1, minus 1, 0, all those things, they fall into place. So I'll just shade this region here. So this region is my region, y is less than 2. This line here is at the line y is equal to 2. This is the boundary. Next, we're looking at understanding simultaneous linear inequalities. I know we've done simultaneous linear equations here, but we're looking at simultaneous linear inequalities. So it just involves finding the region that satisfies 2 or more inequalities at the same time. So you have like 2 or 3 different inequalities and you are drawing them on the same graph. You are drawing them on that same Cartesian plane. You want to see where the 2 of them or the 3 of them intersects. That means the region that actually satisfies all of them at the same time. So the solution is the intersection of the shaded regions that satisfy each inequality. Let's see the steps. First step is to graph each inequality on the same coordinate plane. Use solid or dashed lines based on the inequality sign. We talked about this before. Shade the region that satisfies each inequality, and then the common shaded region is the solution to the simultaneous inequalities. So these are 4 simple steps when you're given this type of questions. Let's see an example. Example 9 states that we should illustrate the following on graph paper and shade the region which satisfies all the 3 inequalities at the same time. Minus x plus 5y is less than or equal to 10. 3x minus 4y is less than or equal to 8, and x is greater than 1. This is taken from WAEC 1988. Let's solve it. So we have these 3 equations. Then for us to plot it, we need to know the boundary. What do I mean? If I say x is greater than 1, x starts at 1, right, and then moves further. So if this is our graph and this was x is 1, so this is where x is 1 will start from, and it will go to the right because x is greater than 1. But on that line that we're going to draw, it will either be a solid line or a dashed line, depending on the inequality. So if it's just greater than, it's going to be a dashed line. If it's greater than or equal to or less than or equal to, it's going to be a solid line. So we need to know the boundary. So let me start from this. So I'll just say at the boundary, our x is just equal to 1. That's all. Same thing here too. I'll say at the boundary, 3x minus 4y is equal to 8. So I could just make y sub the formula and say minus 4y is equal to 8 minus 3x. So if I divide both sides by minus 4, this will be divided by minus 4. This will also be divided by minus 4. So my y will be equal to minus 2 plus 3 over 4x. Right, and then I'll now choose 2 points to plot. So I could say when x is equal to 0, y is equal to minus 2 plus 3 over 4 multiplying 0, and that will be equal to, y will be equal to minus 2. Now I could come here and see when y is equal to 1. I'm choosing 1 because I feel like it's going to be easier for me to resolve, right? I don't want to have maybe 1.34 which would be hard for me to plot, so I just chose something easy. So this would be 1 will be equal to minus 2 plus 3 over 4x. So if this minus 2 comes over here, that will be 1 plus 2 is equal to 3 over 4x, and that will be 3 is equal to 3 over 4x. So if I cross multiply, this will be 3 times 4 is equal to 3x, and I divide both sides by 3, my x will be equal to 4. So when y is 1, my x is 4. Then for this last one, I'll just say at the boundary, minus x plus 5y equal to 10. So when x is equal to, okay, before I do when it's equal to 0, let me make y equal to the formula. So that will be 5y is equal to 10 plus x, and then if I divide both sides by 5, my y is equal to 10 plus x all over 5. So when x is equal to 0, y is equal to 10 plus 0 all over 5, which is equal to 2. And then when y is equal to 0, 0 will be equal to 10 plus x all over 5. If I cross multiply, that will be 0 is equal to 10 plus x, and my x is equal to minus 10. So we have these 2 points. Now let's plot it. We say that the smallest value of x is minus 10. So for the x-axis, I could just say let 2 centimeter represent 2 units. And then for the y-axis, I will say, let me see, what's the highest value of y that we have? Minus 2. So let's 2 centimeter represent 1 unit. If you have not watched the video on linear graphs, I will encourage you to do so. We said that each of these boxes is 2 centimeter, 2 centimeter, 2 centimeter, 2 centimeter. So each of these 2 centimeters should represent 2 units on the x-axis, and each of these 2 centimeters should represent 1 unit on the y-axis. So let's plot. So I'll draw my graph like this, somewhere around here. This is my y-axis, and this is my x-axis. So we're told that in this one here, when x is 0, y is 2, before then I have to label. So let's label. These are 0 points. 2 centimeter is 2 units. So this will be 2, 4, 6. This will be minus 2, minus 4, minus 6, minus 8, minus 10. And this will be minus 1, minus 2, 1, 2, 3, 4, 5, 6, 7, 8. Right? So when x is 0, y is 2. X is 0, y is 2. When y is 0, x is minus 10. So this is minus 10, x is minus 10, y is 0. So these are the points here. So now let's draw the graph. Now, will it be a solid line or will it be a dashed line? It's going to be a solid line because of the less than or equal to sign. There's an equal to sign, so this will be a solid line. And I'll label it as minus x plus 5y is less than or equal to 10. And then for this one here, when x is 0, y is minus 2. X is 0, y is minus 2. This is the point here. And then for this one, when x is 4, y is 1. X is 4, y is 1. So this is it here. So you can see that they intersect each other. So this line here is the graph of, let me just write it down here. So this is 3x minus 4y is less than or equal to 8. Solid line because of it's also a less than or equal to. And then for this one, x is greater than 1. So where is x 1? Here. To be somewhere, but it's going to be dashed line because there's no equal to sign here. So we'll just take this. So this is 0.2, 0.4, 0.6, 0.8. This is 1. Right, so I'll just draw this. But now it's going to be a dashed line. So this one is a line of x is greater than 1. So if you notice it here, it forms a shape here. This is where the three of them intersect. This is where the three of them intersect here. And it is that portion where they intersect that you will now shade. Some books will shade every other part, and they will not shade the part that they intersect. But you have to read the question clearly. The question says that we should shade the portion that intersects. And I think for me, I'm going to be shading every portion that intersects. So basically, this is the solution to our question. Example 10 now says that we should use a scale of 2 cm to 1 unit on both axes. Draw on a graph the region which satisfies the following inequalities simultaneously. Y is less than x plus 1, 2y is greater than or equal to minus 2x plus 3, 2x is less than 3, and y plus 1 is less than 0. This is from GC 2015. Let's solve it together. So for this, we just say at the boundary, y will be equal to x plus 1. So when x is 0, y will be equal to 0 plus 1, which is equal to 1. And then when y is 0, that will be 0 is equal to x plus 1, or x will be equal to minus 1. Here we say at the boundary, 2y is equal to minus 2x plus 3. Then y will be equal to minus 2x plus 3 all over 2. So when x is 0, y will be equal to 3 over 2. And then when y is 0, that will be 0 is equal to minus 2x plus 3 all over 2. And I would say if I cross multiply, minus 2x plus 3 will be equal to 0. And minus 2x will be equal to minus 3. And x will be equal to 3 over 2. Same here, so we say at the boundary, 2x will just be equal to 3. So x will be equal to 3 over 2. And here at the boundary, y plus 1 will be equal to 0. So our y will just be equal to minus 1. And we're told that we should use a scale of 2 cm to represent 1 unit on both axes, 2 cm to represent 1 unit on both axes. So because we don't have a very large out value, I can just put my graph anywhere and draw. So this is the y-axis and this is the x-axis. So this is 0, this is 1, this is 2, 3, 4, 5, 6, 7, minus 1, minus 2, minus 3, this is minus 1, minus 2, this is 1, 2, 3, 4, 5, 6. So for this one, when x is 0, y is 1, x is 0, y is 1. When y is 0, x is minus 1. So I'll draw this. This would be a dashed line because it's just less than. So this is the graph of y is less than x plus 1. Try to put it inside the region that it studies to, because if this is y and this is, and we're saying y is less than x plus 1, so it will be somewhere here, right? So this is like the shaded region for this place. And for this one, it is like 2y plus, and then for the next one, which is 2y is greater than or equal to minus 2x plus 3. When x is 0, y is 3 over 2. X is 0, y is 3 over 2. That's 1.5, 1.1, 1.2, 1.3, 1.4, 1.5. When y is 0, x is 3 over 2. So this is 1.1, 1.2, 1.3, 1.4, 1.5. So I'll join this 2, but it's going to be with the straight line. Oh, I think I must have maybe veered a little bit, but that's fine. But you get the idea. When x is 3 over 2, this is for 2y is greater than or equal to minus 2x. Then 2x is less than 3. here we're looking at where x is equal to 3 over 2. That's the boundary line. So where is x 1.5? This is where x is 1.5. So just draw the boundary line here. Of course, it's going to be in dashed line because of the less than. So this will be in dashed line. So this represents 2x is less than 3. And then the last one where y is minus 1. So this y as minus 1 with dashed lines. So you can see, if you look at all these places, just look for the place where all 4 are enclosed. So look at this. This 1, this 2, this another. This, you can see that it's a closed loop. So when you're giving like more than 2, you will see a place where they close. Just like in that previous example, you see where they close. Where they close is really your shaded region, right? Just look for where they close. So you don't need to bother yourself. Just look for where they close. And this is our shaded region, because I said we should shade the region that pertains to it. So this place here, is that's simple and short for questions like this. Example 11 now states that we should illustrate the following on the graph paper and shade the region which satisfies the two inequalities at the same time. Y is greater than or equal to 2x minus 1 and y is less than x plus 1. Let's solve it together. So for this, we have to find what happens at the boundary. Our y will just be equal to 2x minus 1. So when x is equal to 0, y will be equal to 2 open bracket 0 minus 1, which is equal to minus 1. And then when y is equal to 0, that will be 0 is equal to 2x minus 1. 2x is equal to 1, and then our x will be equal to 1 over 2 or 0.5. So this particular is for this one, and then for this guy here, we can say at the boundary y is equal to x plus 1, and when x is equal to 0, y will be equal to 0 plus 1, which is equal to 1, and then y is equal to 0, that 0 is equal to x plus 1, our x will be equal to minus 1. So we have our points for each of these graphs. You can set right and say x and y. X is 0, y is minus 1, x is 0.5, y is 0, and then for this x and y, x is 0, y is 1, x is minus 1, y is 0. So because the points are very small apart, I could just say for the x-axis, let 2 centimeters represent 1 unit. For the y-axis, let 2 centimeters represent 1 unit. So it's just time to plot. So this would be 1, 2, 3, 4, 5, 6, 7, 8. For the y-axis, this will be minus 1, minus 2. So for the x-axis, this will be minus 1. This will be 0. This will be 1, 2, 3, 4, 5, 6, 7. So when x is 0, y is minus 1. This point here. When x is 0.5, y is 0. So this is 0.1, 0.2, 0.3, 0.4, 0.5. These are points. So because it's greater than or equal to, I'll use a straight line, solid line for it. So let's see. This line in itself is the line of y is equal to 2x minus 1, because it's the boundary line, right? And this is greater than or equal to 2x minus 1. So this upper part will be our region. That will be y is greater than or equal to 2x minus 1. It will be at this upper side. And then for this one, when x is 0, y is 1. X is 0, y is 1. X is minus 1, y is 0. So x is minus 1, y is 0. So this point here. But it will be a dash line because it's less than. So these are the small things that you need to take note of when you're doing it. So this line here is for y is equal to x plus 1. But the region that satisfies this place, where it says y is less than x plus 1, is this inside here. So this y is less than x plus 1. So you can see that this one here, the region that tallies to it is up here. This one here, the region that tallies to it is down here. This is the point where the two graphs intersect. This is the point. If I were to shade this one here, I'll have shaded this upper part, right? This upper part. Let me use a pencil to show you. I'll have shaded this part here, all these parts here, right? And if I were to shade for this one, I'll have shaded just this, all these parts here, down here. So you can see the places where they just intersect, where this one intersects and this one intersects, is this region here. This region. So this region is our region in focus. So you take your pencil or your biro. I think for WAEC you have to use pencil. I'm using biro so that it will be clear for everybody to see.
and you shade it. So when you shade it, the shaded region is the point of reference or what the question told you to do in this particular case. Always remember to use a solid line if it's greater than or equal to. If it's just greater than or less than, use a broken line. And that solves this particular question.
Last question is taken from New General Mathematics, and it says that what are the three inequalities we define the unshaded region R? So this is the unshaded region R. What are the three inequalities which define the unshaded region R in the figure below? Remember, we've always been dealing with the shaded region as our point of contact, but now they're saying that what portion defines the unshaded region R in the figure below. Let's solve it together. So to solve this question, if you look at the video we did on linear graphs, we said that we can find the equation of a line if we're given a point that is the x and y coordinate of a point, and then we have the slope. Then we also said that we can also find it if we're given 2 points, but all of them is still the same equation. So we had something like this where it said y minus y1 is equal to m open brackets x minus x1. Great. But remember, m is the gradient, so gradient is always like y2 minus y1 all over x2 minus x1, right? So multiplying x minus x1, this would be equal to y minus y1. So if I cross multiply, that would be y minus y1 x2 minus x1 is equal to y2 minus y1 then x minus x1. So if I make all the y's to be in one side and all the x to be in one side, that will be y minus y1 all over y2 minus y1 is equal to x minus x1 all over x2 minus x1. And if you look at it, this was the equation that we had when we said if you have 2 points, you can be able to find the equation of the line. I just said I should prove it. I didn't prove it in that particular video, but when you prove it, you realize that it's the same formula for both cases. So if I make this line 1, this line 2, and this line 3, you should be able to find the equation for each of them, and then from the equation be able to find the inequality for each of them. So I'll just say for 1, I'll pick 2 points. So basically for this one, we just have a straight horizontal line parallel to the x-axis and cutting across 2. So we know that for the first one, the equation of that line is y is equal to 2. We know that already based on past precedence. But look at this is a dashed line, right? And if you look at the question, it is the unshaded region we're looking at. The unshaded region is this upper part. This upper part is the one that is greater than 2, where you have 3, 4, 5. So of course my y would just be greater than 2. It's just greater than 2 because it is a dashed line. If it was a solid line like this line of equation 2 or graph 2, it would have been greater than or equal to. So let me say for 2, I can take 2 points. Let me take this point minus 5, 3. The x comes before the y, and then the second point would be, let's say, minus 2, 0. So let's solve. This is going to be my x1. This is going to be my y1. This is going to be my x2. This is going to be my y2. So I'll just substitute. That will be y minus 3 all over 0 minus 3 is equal to x minus 5 all over x2 is minus 2, so that will be minus 2 minus 5. So if I resolve this, this will be y minus 3 all over minus 3 is equal to x plus 5 all over minus 2 plus 5. And if I resolve this, this will be y minus 3 all over minus 3 is equal to x plus 5 all over 3. And if I cross multiply, that will be 3 open brackets y minus 3 is equal to minus 3 open brackets x plus 5. So 3 times that will be 3y. This will be minus 9 is equal to minus 3x minus 15. So let's take all of these guys to the other side. That will be 3y is equal to minus 3x minus 15 plus 9. So this will be 3y is equal to minus 3x minus 6. And if I divide both sides by 3, this will be y will be equal to minus x minus 2. This is the equation of the line. Let's now see what the inequality will be. So as you can see, this is a line. The unshaded region is the part of the greater than, because it's minus 2. The unshaded region is above that particular line, right? So we can say that it's going to be greater than or equal to. So I'll just come here and say the equation of this line is, okay, let me just say equation 2 will just be y is greater than or equal to minus x minus 2. That's fine. So we need to find for the last equation, which is equation 3. So I need 2 points. Let me just do it somewhere here. So I'll say for 3, we'll just pick 2 points. Let me say 0, 0, and then another point. Let me say 1, 3. So now let's plot. So that will be y minus y1 all over y2 minus y1 is equal to x minus x1 all over x2 minus x1. So let me just, this is my x1, this is my y1, this is my x2, this is my y2. It's always good to write it down like this so that you don't forget to, and you don't mix up each of these values. So that will be y minus 0 all over y2 is 3. That will be 3 minus 0 is equal to x minus our x1 is 0 all over 1 minus 0. So that will be y over 3 is equal to x over 1. So if I cross multiply, that will be 3x is equal to y, or we can say y is equal to 3x. So let's see the sign that it will take. So this graph 3, first thing is that you notice that the third graph is a dashed line. So that will be either less than or greater than. And then the unshaded region, look at this line here. The unshaded region is the one that is up here, which is greater than. So our inequality will be, I'll just say equation 3 would just be, in fact it should never be equation, right? Equation is like you are saying is equal to, so that should be inequality. So pardon my English, that would be y is greater than 3x. So this should be not be equation, this should be inequality. See how semantics is very important. So this should not be equation, this should be inequality 2, and this should not be equation 2, and this is inequality 1. I know the solutions was all over the place, right? But you get the idea. We first started with proving our equation, and then we now started picking 2 points. So from this one, we needed only one because it's a straight line, and then we started picking all these other points. For this equation 1, we needed 1 point because it was parallel to the x-axis, meaning that it was giving us definite value for y and for inequality. For this one, we needed 2 points. Using our formula, we found the equation, and then from the equation, we found the inequality. Same thing too for this one. We needed 2 points. We found the equation, which is y is equal to 3x, and then from there we found the inequality. So this is how you solve questions like this. Look at the patterns, look at what to know, and solve. So with this, we've come to the end of linear inequality. I hope you took time to watch the video. Like the video if you found it useful. Subscribe to our channel if you have not. If you know someone that this channel will help, please spread the word. Share the link to somebody that you know that is struggling with maths or that wants to get better in maths. I'll see you guys in the next video.